Hello friends, welcome to my channel. In this video I will cover Vizag Steel Management Trainee 2015 paper. Solution I will give. Technical parts only I will. This is the part 9 of this series. Question is, if R1 and R2 are the inner and outer radius of a cylinder, the heat conduction through a cylinder is proportional to, for a hollow cylinder, Q dot is delta T divided by log R2 by R1 divided by 2 pi KL. So it's proportional to D, 1 by log R1 by R2. This is the case for cylinder. For sphere also, sometimes they may ask. So you remember that for sphere also. In ISRO already 2 to 3 times they asked this question. So you remember both. 4 pi K R1 R2. When K is the thermal conductivity, tau is the density, and Cp is the specific heat of a substance, then thermal diffusivity is given by. This question was also so many times asked in lot of examination, RRB, Public Service Commission examination, PSU and IAS, ISRO also. So this is very important. Thermal diffusivity, alpha equal to heat conducted by heat stored. Heat conducted divided by heat stored. K by rho Cp. Unit also important. Meter square per second. They may ask the dimension, so unit also you remember. Sometimes problems also based on this formula they are asking. So here rho, they took tau in this question, so K by tau Cp. A is the answer. If one of the two fluids flowing through a heat exchanger of NTU equal to 2 remains at constant temperature throughout the exchanger length, the effectiveness of the heat exchanger will be, effectiveness of the heat exchanger we have to calculate. Remains at constant temperature, one fluid having constant temperature, so boiling and condensation. That time C, capacity ratio, C minimum by C maximum is 0 and NTU given 2. So we have to calculate effectiveness for parallel case. Formula is 1 minus e to the power NTU into 1 plus C divided by 1 plus C. C already capacity ratio we got 0. So 1 minus e to the power NTU by 1 equal to 1 minus e to the power minus 2. NTU value already we got. So B is the answer. For counterflow heat exchanger also you can check effectiveness equal to counterflow 1 minus e to the power minus NTU into 1 minus C divided by 1 minus c into e to the power minus ntu into 1 minus c. C value 0, divided by 1. NTU value is 2, 1 minus e to the power minus 2. Same answer we are getting, B. Then question is Nusselt number divided by Reynolds number into Prandtl number. Stanton number is wall heat transfer rate divided by heat transfer by convection. So ST equal to Nusselt number divided by RE into PR, or it's rho Cp to V. So from option B is the answer. Also two more numbers are important. Rayleigh number equal to Grashof number into Prandtl number. Pacelet number is Reynolds number into Prandtl number. From linear programming, the constraints in a given situation are found to be as follows. These are given. Then objective function which is to be maximized, this one given. Here no need to draw the graph. Directly from options you can solve this question. Maximization, P maximization for A, you can check. 5 into x value is 11 plus 4 into y value is 6. Like this we can calculate 55 plus 24, 79. Then go for B. So for option C we will get the maximum value 80 we are getting for option C. So C is our answer. Jobs going behind the schedule are conveniently shown in A. milestone chart, B. pie chart, C. bar chart, D. Gantt chart. Gantt chart is our answer used for production schedule. This one also so many times asked in IAS and ISRO examination also. Efficiency of an engine is defined as output by input, or input is output plus losses. So A also correct, B also correct, C also correct. D is our answer, all of these. Viscosity has dimension of viscosity Pascal into second, Newton per meter square into second, kg into meter per second square into second per meter square. If you solve this one, kg divided by second into meter. So kg for mass, second time, length. So m by lt. D is the answer. The discharge in meter cube per second for laminar flow through a pipe of diameter 0.04 meter having a center line velocity of 1.5 meter per second is discharge. We have to calculate diameter given 0.04 meter, center line velocity is maximum velocity 1.5 meter per second in a pipe, so V average is half of V maximum. If you solve, we will get 0.75. We have to calculate the discharge. Q is A into V. So pi by 4, d square is 0.4 into 0.04 into area, then average velocity 0.75. Divide 100. Here also divide 100. Divide 100. We will get 4 cancel. Then 4, 25, 3 pi by 10,000. D is the answer. Unit is meter cube per second. Minor losses in a piping system are A less than the friction losses F FLV square by G D square. B due to the viscous stresses. C assumed to vary linearly with the velocity. D found by using loss coefficients. D is our answer. Power required to drive a centrifugal pump is proportional to. This type of formulas also they are asking for problems. You have to use this type of formula. Sometimes IAS and ISRO also they are asking this type of questions. P is proportional to power, head and discharge. N square, NQ. All three you have to remember. And for diameter, D square, DQ, D to the power 5. This one also you remember. For problem solving, these formulas are very useful. So power required for power, this one you have to use. P is proportional to NQ. C is our answer. Specific speed of a centrifugal pump. Both pump and turbine, they are very useful. For turbine, specific speed. For pump, for turbine, N root P, H to the power 5 by 4. Here N root Q, H to the power 3 by 4. H is manometric head here in case of pump. Here P in kilowatt. This unit also you have to remember. So in this question, for centrifugal pump, option A, N root Q H, not possible. B, N root H by Q, not possible. This is also not possible. So D is the answer, none of these. The Francis formula for discharge over a rectangular wire without end contraction is, this formula directly you have to remember. D is the answer. Q equal to 1.84 CD into B, H to the power 3 by 2. One more thing is important here. For rectangular and triangular wire and notch, Q is proportional to, for rectangular case, H to the power 3 by 2. For triangular case, Q is proportional to H to the power 5 by 2. Sometimes they are asking also based on this formula. So these two also you remember. In order to replace a pipe of diameter D by n parallel pipes of diameter small d, The relation used is parallel connection. So for parallel connection we know Q equivalent equal to Q1 plus Q2 plus up to nth pipe discharge. And one more thing is HF1 equal to HF2 equal to HF2 HF nth pipe, and HF formula is head loss due to friction FLQ square by 12 d to the power 5. This formula we will use. One more formula also remember, sometimes this is also useful, V square by 2GD. So parallel connection will do Q equivalent equal to Q1 plus Q2 plus to Qn. All are having same discharge, so n into Q1, Q equivalent equal to n into Q1. HF is FLQ square by 12 d to the power 5. So from here Q square is 12 into HF into d to the power 5 by FL, or Q you will get 12 HF d to the power 5 by whole to the power 1 by 2. So this one we will use here. Q equivalent HF capital D to the power 5 divided by FL whole to the power 1 by 2 equal to n into 12 HF small d to the power 5 divided by FL whole to the power 1 by 2. So 12 HF FL cancel, then d to the power 5 equal to here d to the power 5 by 2, here also you take d to the power 5 by 2 equal to capital D to the power 5 by 2 divided by n. So d equal to d to the power 5 by 2 divided by n whole to the power 2 by 5. Then you will get d equal to capital D divided by n to the power 2 by 5. This is our answer. So from option you have to check. Small d equal to d capital D divided by n to the power 2 by 5. A is our answer. This is little bit time taking question, but this is very important for ISRO, IAS and GATE exam. So in Vizag still, if you are getting time, then you solve this one. Otherwise you leave this question. Otherwise you directly remember this formula. For Q square you will get n to the power 2 term. For d to the power 5 you will get n to the power 2 by 5 term. So from options also you can solve this one. Optimum reorder quantity is Q star 2DCO divided by CH. CO is ordering cost, D is annual demand, CH is holding cost. So from options, option A, 2 into annual unit usage, this is D. Cost for setup or order, this is CO. Cost per unit and percentage annual carrying cost. So if you multiply these two, you will get CH. So A is our answer. There were products P and Q with the following characteristics: demand, ordering cost and holding cost given. EOQ of product P divided by EOQ of product Q. You have to calculate. So Q star for P, 2 into D is 100, then ordering cost CO is 50, holding cost is 4, root over you have to, so is 25 root over of 100 into 25, so 10 into 5 you will get 50. Like this, if you calculate Q star for Q, you will get 2 into D is annual demand is 400 into CO ordering cost is 50 divided by 1. So 100 into 400 whole root over 10 into 20. You will get 200. If you divide these two, 50 by 200, you will get 1 into 4. A is the answer, but official answer is D. For a product, the forecast and the actual sales for December 2008 were 25 and 20 respectively. If the exponential smoothing constant alpha is taken as 0.2, the forecast sales for January 2009 would be how much? In this given, if December is 25, demand for December is 20, smoothing constant alpha given 0.2, and our formula is Fn is Fn minus 1 plus alpha into Dn minus 1 minus Fn minus 1. So F January equal to F December, forecasting for December, plus smoothing constant into demand for December minus forecast for December. Put the values, 25 plus 0.2, here you will get 20 minus 25, so 25 minus 5 into 0.2 or 2 by 10 will get 1. 25 minus 1, answer is 24. So forecasting for sales January 2009 is 24. C is the answer. A helical coil spring with wire diameter small d and mean coil diameter capital D is subjected to axial load. A constant ratio of capital D and small d has to be maintained such that the extension of spring is independent of capital D and small d. What is the ratio? We know our formula. K is G d to the power 4. K is stiffness 64. Coil radius is capital R. number of coils n. In D term, if you small d is wire diameter 64 d by 2 qn, will get g d to the power 4, then 8 dqn. This formula is very useful. So many times they asked in GATE, IS and other examination also. So, and one more thing is important. Deflection or extension K into delta is W load, or deflection or extension delta is W by K. So put the value of K, will get W into 8 capital DQ, number of turns, divided by G small d to the power 4. So extension is proportional to capital DQ divided by small d to the power 4, wire diameter to the power 4. So from option A is our answer. Extension of the spring is independent of capital D and small d ratio. Thank you friends. Thank you for watching my video. Thank you.